Social Work, former Dean, Research and Publication Division, GNLU, Gujarat National Law University, Gandhinagar. I would like to give a brief profile of our esteemed resource person. Dr. Ambati Nageswar Rao is a distinguished academician, researcher, and social entrepreneur with a multifaceted career spanning social work, legal incubation, and academic leadership. Currently, he serves as a Dean of Research and Publication and Director of the GNLU Legal Incubation Council, Gujarat. He is also visiting research fellow at Fried University, Berlin, and visiting faculty at Andani Institute of Infrastructure Management, Ahmedabad, and also visiting faculty at Ganpat University, Gujarat. He has over 12 years of teaching and research experience at Gujarat National Law University, Gujarat. He has more than 20 research paper publication in the area of social entrepreneurship and disability studies, and he also published many articles with Says, Wiley, Routledge, Robert, etc. And he has done 7 research consultancy projects funded by various organizations, including NCRT, ICSSR, AICT, etc. He is extremely involved in training social entrepreneurship, social business model, research methodology, data analysis using SPSS, JMOV, NaviBo, systematic literature review, bibliometric analysis, and meta-analysis, etc. Board is yours. Please take your time. You can start your session, please, sir.
Thank you, Professor. Thank you so much for the nice introduction. I'm just starting my session. I hope I'm audible to all of you.
Yes, very loud and clear, sir.
Yes, ma'am. Thank you so much. Yeah, thank you, ma'am, once again. First of all, I would like to thank all the organizing committee members, starting with the Indian Sociological Society, Southeastern University of Sri Lanka, and Integrated Institute of Disaster Management. And I also like to thank organizers from Southern Field College, Darjeeling, JP College of Arts and Science, Tamil Nadu, Standard College, Manipur. So I would like to thank all the organizing committee members, all the participants, and for giving this opportunity. Coming to the session, as you all know that today and tomorrow, we have some inferential statistical test. So as a part of quantitative data analysis, I'm looking at the schedule. Yesterday, we had an understanding about what are the descriptive statistics. As a researcher, one can conduct it. As a part of my session today and tomorrow, we are going to discuss about how one can start with the inferential statistics. What are the inferential statistics? How to decide whether to go for descriptive statistics or inferential statistics. And within the inferential statistics, what are the different kind of statistical tests one can conduct it? And how to choose statistical test within the inferential statistics. And I'm also going to discuss as a part of today's session, comparison-based test. So we have t-test, ANOVA. Within the t-test, we have one sample t-test, independent sample t-test, paid sample t-test, and one-way ANOVA. We are going to discuss as a part of today's session. Tomorrow, I'm going to talk about chi-square test, correlation test, and regression. So altogether, today and tomorrow, we are going to cover some basic level to some advanced level statistics. We'll discuss it. I'm not sure how many of you are joining with a laptop or PC. That is completely, maybe after some days, maybe after finishing the session, you can watch it. Only one suggestion is that if you start practicing it, you may learn more. Otherwise, it looks a little bit, may not be your cup of tea. I'll try my best to reach each one of you, but I have my own limitations. Feel free to stop. So I'm not here to complete the syllabus also. So we can go as per your requirement, right? So these are some of the references. I have already shared one or two books with one book with Professor Benitz. I also shared a couple of soft copy sample data sets. So in case we are interested, after the session, we can start practice the same. Now, coming to the data analysis as a part of quantitative. Yesterday, we had discussion about descriptive statistics, like how to prepare the mean, median, mode, how to prepare the standard deviation, variance, how to prepare the cross tabulation charts, how to choose the right chart. These were all covered, I believe, as a part of yesterday's session. Now, coming to the today as a part of today's session, inferential statistics. Now, when it comes to the difference between descriptive statistics and inferential statistics, the main objective of descriptive statistics is to describe what you are observing it, what you're studying it about particular phenomena. So, with the help of measures of central tendency, measures of dispersion, and we'll try to describe what you are observing it, what you're trying to study. Whereas when it comes to the inferential statistics, as a researcher, I just want to come up with some conclusions. I want to infer my findings with the rest of the society or rest of the population. So I'll take the help of framing the hypothesis as a part of inferential statistics. So when it comes to descriptive statistics, my main objective is to describe like average, mean, median, mode, central measures of central measures of dispersion, variation. I'll also take the help of single frequency table, cross tabulations, so on. Whereas when it comes to the inferential statistics, with the help of framing the hypothesis, I'm going to test my research hypothesis. Maybe I'm coming with a particular theory. I want to test the particular theory. Or if I'm coming with a particular research hypothesis, I want to test the particular hypothesis. So, to conduct the inferential statistics, we should also know how to frame your hypothesis, how to test your hypothesis. In coming slides, I'll touch a little bit upon it, how to frame the hypothesis, or at least what is the testing procedure of hypothesis. Now, within the inferential statistics, we have different kind of statistical tests, which I'm going to cover today and tomorrow. But within the inferential statistics, there are two types of statistics. We can divide statistics into two types within the inferential. First one is parametric statistics. Second one is non-parametric statistics. As a researcher, if you want to go for parametric statistics, one has to fulfill certain assumptions, like how we have educational qualification, like eligibility criteria. Similarly, if you want to choose any particular statistical test, we should know that we have to fulfill certain assumptions, certain criterias. Like, for example, we have purposive sampling technique. How we'll talk as a part of non-probability sampling technique, certain inclusion-exclusion criterias. When it comes to choosing inferential statistics, we have certain assumptions that are supposed to be fulfilled. If you're able to fulfill that assumptions, we'll go for parametric statistics. If you're not able to fulfill that particular assumptions, we'll call them as a non-parametric statistical test. As far as rigorousness is concerned, parametric statistics is considered as more robust, more rigorous as compared with the non-parametric statistics. But what exactly the assumptions? The assumptions or criteria differ from test to test. The assumptions, criteria are differ from test to test. So, right? So let me see one by one. In coming slides, as we'll start with the t-test. Within t-test, we have three types of statistical test, like one sample t-test, independent sample t-test, paid sample t-test. To take particular statistical test, we should have to fulfill certain assumptions. So I'm going to talk about the assumptions with one by one statistical tests that we're going to conduct. And when it comes to deciding parametric, non-parametric, not only assumptions, you also need to know what are the types of data that you have it. Let's take, for example, in my first slide, imagine that this is my research tool, the tool that I'm going to use as a part of my data collection. This is my research tool that I would like to collect the data from a respondent. As a part of my PhD thesis, imagine that I have around 34 questions or 40 questions. Some of you might be having only 10 questions. Some of you might be having 200 questions. Irrespective of number, irrespective of number of questions in your research tool, if you want to look at the quantitative study, you are going to classify your data in the form of four classifications. We are going to have four types of data. As you all know that nominal data, ordinal data, interval data, ratio data. When I call it as nominal data, what are the data if I'm going to classify in the form of specific labels, specific categories? I call it as a nominal data. Whereas when it comes to the ordinal data, if I'm going to put my data in the form of ranking, in the form of ordering, in the form of positioning, like for example, if I'm collecting data from all of you, if I'm going to convert your quantitative data in the form of qualitative data, like low income, middle income, high annual income. If I'm going to put it like this, some order or some position, like first rank holder, second rank holder, third rank holder. Or let's take, for example, educational qualifications, SSC, Inter, degree, PhD. Or for that matter, like for example, if you have Likert scale, strongly disagree to strongly agree. If I'm going to put it in the form of ranking, in the form of order, we call it as a ordinal data. Next one, we have interval data, ratio data. We can call it as a continuous data and discrete data. If I'm going to measure your height, somebody says that 5.6 feet. Somebody says that 6.2 feet, 6.1 feet. When I talk about weight, 56.5 kgs, 70 point, if I'm putting in the form of decimal, I'm going to call it as a continuous data. If I'm going to ask how many children do you have, somebody says that 2 children, 3 children. If I'm going to ask what is your annual income, you're going to say that my annual income is 50,000 or 60,000, right? If it is going to be like this, that comes under discrete data. So whatever the data that you have as a part of your research tool, you are going to classify under four categories: nominal data, ordinal data, interval data, and ratio data. Having levels of measurement is also going to help you to decide whether to go for parametric statistical test, non-parametric statistical test. Though I have mentioned here as a part of parametric test only interval and ratio, we're also going to use nominal data. It depends on the type of the test. That's why I mentioned it. Every statistical test have different assumptions, different data requirements. We are going to see one by one while conducting each test. Now, when it comes to the parametric statistical test, as a part of comparison-based test, we have t-test, ANOVA, we have it. If you're not able to fulfill assumptions, we are going to have alternative tests like Mann-Whitney test. Similarly, Pearson correlation, we are going to have Spearman correlation test, and we also going to have chi-square test. For every parametric statistical test, there is an alternative non-parametric statistical test. If you are not able to fulfill any of the assumptions or any of the data requirements, one can go for non-parametric statistical test. Parametric statistical is considered as more powerful, and whereas non-parametric is more flexible. Even if your data is not distributed normality, I'll talk about it, what is normality, in coming slide. Okay, so these are some of the important requirements one should know before choosing what is parametric, what is non-parametric statistical test. We have different kind of tests. We have it. Having understanding about levels of measurement like nominal data, ordinal data, interval data, it is going to help us how we are going to choose right statistical test. Let's take for example here. I just want to spend some time with you here. If I'm going to have two continuous variables, like two quantitative variables, I can go for correlation test. I can go for regression test. If I'm going to have, let's take for example here, discrete, how many samples? I can go for, if I have only one data, one quantitative variable, I'll go for one sample t-test. If I'm going to have one independent variable, one dependent variable, I'll go for independent sample t-test. So instead of discussing here, let me show you one by one. One of the important requirement for choosing parametric, non-parametric is that the data that you collected, it must have distributed normality. Your data must have normality distribution. What is normality? What is normality distribution of the data? As you can see this particular slide here, this is the data we have collected. I have collected as a part of my research work. Once I'm going to put this particular data in the software, maybe an Excel sheet, any of the software, if I'm going to get the bell-shaped curve, it means my data distributed normally. But how to understand it? How to understand further? Let's take, for example, if I collected data from 100 people, minus 1 standard deviation plus 1 standard deviation, it indicates that 68% of your data is falling here. 34 plus 34, 68% of your data is falling between minus 1 standard deviation plus 1 standard deviation. It means 50% of the data is left side, 50% of the data is right side. Left side 50%, right side 50%. The mid value, the average, the point that you're seeing right now, this is called mean. It means mean is equal to median is equal to mode. Mean is equal to median is equal to mode. This is a mean value here we have it. Okay. Now, as you all know that when it comes to the level of significance, generally we take 0.05%, 0.01%, 0.10, right? So if I'm going with 95%, 90% confidence interval, I can go with the 95% confidence interval. I can also go with the 99% confidence interval. Now, based on that, we are going to see here the rejection area and acceptance area. I'll talk about what is rejection, what is acceptance in coming slide. Right now, here the mid value, once you prepare your histogram, it is going to show you how your data distributed normally. If I'm getting curve like this, let's say for example, if I'm getting curve, if I'm getting exactly bell-shaped curve, it is fine. But sometimes what happens is I'll get skewed data. Left side, this is called left skewed data. This is called right skewed data. Means the mid value is not equal. My data is not distributed properly. Let me put it simple with a simple example here. Let me put it in simple example. If I want to talk about my placement, my university, my college placement record, what I'm going to do is I'm going to collect the data from 10 students for the sake of simplification. I'm collecting data from 5 students. I'm taking the total annual package. Let's take, for example, student number 1. He is getting around 10 lakhs rupees per annum. Student number 2, 12 lakhs, roughly. Student number 3, around 15 lakhs. Student number 4, around 20 lakhs. Student number 5, around, imagine that 1 crore, 1 CR. Okay. If somebody asks what is your annual average package of your university placement record, how I'm going to tell in general, I'm going to calculate 1 plus, 2 plus, 3 plus, 4 plus, all the 5 people annual package I'm going to calculate divided by 5. So this is total divided by 5 people. How much I get it? 1 crore, 120, 140, 140, 150, 162. 1 crore 62 divided by 5 people. How much I'll get it? Anyone? Do you have any? Who can tell me what is the multiplication divided by this? 162 divided by 5. I hope participants are here. Any volunteers?
So 32.4.
52.4. Just imagine that.
32.
32.4.
Just imagine that roughly around 30 lakhs. On average, I'm saying that my university students are getting annual package is 30 lakhs average. Is it correct? Is it the true value that I'm giving to my to the public, the people those who are asking me? Is there anyone getting 30 lakhs? How many people are getting 30 lakhs? He is less than 30, he is less than 30, he is less than 30. Only one person is getting around 1 crore. The 1 crore, because of this particular figure, I can see a lot of deviation from the mean. If I keep it like, for example, here, next slide. 30 minus 10,
બસ બસ હવે બહુ જોતા નથી
20 lakhs high for the first respondent.
તો શું દેખો તમે
30 minus 20. So I'm giving the value 30 lakhs is not the right figure. Just because of 1 crore, just because there is a deviant in the mean, the mean value is 30. The mean value is 30, but there are people who are less than 30. Out of 5 people, 4 people are getting less than 30. Only one person is getting about 25 lakhs. Now, the mean that I'm doing is it comes under left or right skewness. This data is not correct. I can able to see as a part of my data, either it can be a skewed data, left, either right. So in that case, I cannot conduct parametric statistical test. The data that I have it is not the right data. I need to remove the outliers. If I don't want to remove the outliers, I should increase my sample size. Somebody suggesting something or adding some point?
ને બસ થેન્ક યુ
Dear participants, please check your mic. I'm not sure you're asking question or you're adding something. Please check your mic. Okay. Now, if my data is distributed normality, I'll go for parametric test. If my data is not distributed, I'll go for non-parametric statistical test. Now, in order to conduct the parametric statistical test, we have various statistical tests. We have it. In order to conduct the parametric statistical test, in order to test your data, whether it's distributed normally or not, first choice is I can go with the help of bell-shaped curve, that is histogram. Second one, as a part of statistical tests like R software, SPSS software, Geomovi software, name it any software, we have certain normality statistical tests are available as a part of our software, which I am going to show you, which we are going to use it as a part of today's session. Now, how to interpret the findings of normality test? As a part of your normality test, if your p-value is going to be greater than 0.05, it means your data distributed normally. In case if your data is less than p-value is less than 0.05, it means your data is not distributed normally. Similarly, we also have skewness and kurtosis values. If value is close to 0 indicates normality, especially when it comes to skewness plus or minus 1. Some people liberal, they say that plus or minus 2 means if value is less than minus 2 or plus 2, that can be considered as a normally distributed data. We also have certain plots, graphical parts, which we are going to do with the help of the data set. Okay. Now, we also have box plot. In addition to histogram, how to read it, how to understand it. When I distribute my data with the help of the box plot, this is the overall 100% of the data that I have it. This is the 100% of the data that I have it. From this point to this point, this is a 25 percentile. This point to this point, this is called 25 percentile. From this point to this mid value, this is called mid value. This is called 50 percentile. This is called mid value, 50 percentile. From here to here, this is 75%. Let me take it, this one. This is called 75 percentile data. And from here to here, 100% of the data. With the help of the box plot, we can able to understand, do we have any kind of outliers at the bottom level, at the upper level? So we'll check with the help of the data set in coming slide. So let me start with the first test, that is one sample t-test. We are going to start with the first one sample t-test as a part of comparison based. As a part of comparison based test, one sample t-test. As name itself indicates, we are going to conduct one sample. There is going to be one variable that we are going to have it. The main objective of this particular test is to compare the mean of population with the mean, the sample mean. We are going to compare the mean of the population statistically different from known or hypothesized value. Let me give a small example. I'm sure participants are coming from different academic backgrounds, not only sociology, in general social science. Imagine that in social science, as for the UGC, in the year 2024, UGC came up with the report, hypothetically, just where I'm giving some small report. I'm just cooking the data. Hypothetically, UGC came up with the report in the year 2024 saying that we have all over India, we have 6,000 faculty members. We have 6,000 faculty members in social sciences. In social sciences, we have 6,000 faculty members. Now, one more, as a part of 6,000, we have it. And 6,000 faculties, their height is 66.5. Mean height. On average, Indian social science faculty height is 66.5 inches. I'm repeating again. There are 6,000 social science faculties in India as per UGC report published in the year 2024. This is called population. This is called population. This is called population. And as for the one of the variable height, there is one variable height. 66 population height is mean height. Average height is the 6,000 people height is 66.5 inches. Okay. If that is the case, if that was a report published in the 2024. Now, as a Dr. Rao, I'm sitting in Gujarat. As a Dr. Rao, I'm working in. Call Pradeep. I'm working currently in Gujarat. I just want to collect the data within the Gujarat state. I want to collect the data from the Gujarat state. And I'm collecting data from 50 people. I'm collecting data from the 50 social science faculties because I can't spend, I don't have that much resources, that much energy, that much time, right? So I'm going to collect the data only from 50 people in Gujarat state. And I'm going to collect their height. One of the variables is height. I'm going to compare the sample mean height with the population mean. Let me put it again. Let me put it here. I have one population. This is from all over India. I have sample that as a researcher, as an individual person, I'm collecting data from the Gujarat. As for the UGC report, which collected data from 6,000 people, average height of social science faculty height is 66.5 inches. This is the population mean with reference to the height. As an individual researcher, I'm collecting data from only 50 people. And I'm going to compare the population mean with the sample mean. Whether the sample mean height is going to be 66.5 or are there going to be any difference? If I want to do this kind of test, I'm going to conduct one sample t-test. Let me give one more example. As you all know that we have a rice bag weight. We have different kgs, 5 kgs, 10 kgs, 100 kg, 20 kgs. We have rice bag. We have 10 kgs bags. We have it. As for the wholesaler, we have 10 kgs bag. Each bag weight is 10 kgs. Now I'm going to start my new rice provision storeroom. At a time, I want to buy 100 bags. At a time, I want to buy 100 bags. At a time, I want to buy 100 bags. So I'm going to buy from this particular wholesaler, give me 100 bags, but I want to test. In order to test it, I'll take around 5 bags. I'll see whether each bag is having 5 kgs or not. Is it coming under is it coming under 9.5 kgs, 9.8 kgs, 9.6 kgs? I just want to compare the sample mean with the population mean. If I'm going to do this kind of comparison, that is known as one sample t-test. This is known as one sample t-test. Now coming to our hypothesis. Where it is, yeah. I'm going to examine the mean of the population statistically different from known or hypothesis value. So this is also known as single sample t-test. In order to conduct the one sample t-test, we required certain variables. We required only one variable. That variable must be continuous data. Please listen. Please let me know if I'm able to reach each one of you or not. In order to conduct the one sample t-test, we required only one variable, but that variable must be continuous data. What is continuous data? We didn't discuss so far. Nominal and ordinal data, we call it as a categorical data. Nominal and ordinal data, we call it as a categorical data. We call it as a qualitative data. Whereas when it comes to interval and ratio, we call it as a continuous data. We call it as a scale data. We call it as a quantitative data. I'm repeating again. This is the most important part. We have 4 levels of measurement. We have 4 types of data: nominal data, ordinal data, interval data, ratio data. Nominal data and ordinal data, we call it as a categorical data. Categorical data, or we call it as a qualitative data. Qualitative data or categorical data. When it comes to interval and ratio, we call it as a continuous data, scale data, or quantitative data. Quantitative data. When it comes to conducting one sample t-test, we required one variable. Variable must be continuous. That is, it can be either interval data or it can be ratio data. That is the minimum first criteria to go for one sample t-test. Second one, scores on the test variable are independent. Scores on the test are basically independent. Means at the time of data collection, I'm not going to manipulate. Means every respondent have their own answers. Every respondent have their own answers. I should not manipulate like first respondent, I didn't collect the data from fifth one. Whatever first respondent said it, I'm going to give the same value to the fifth respondent. That is wrong, right? So every respondent, we are collecting data from every respondent, and that only we are going to include it. Random sample of data from the population. You must have collected data by using random sample technique if you want to go for parametric statistical test. Random sample of data. You must have collected data by using random sample if you want to go for parametric statistical test. Fourth criteria, normality distribution. I'll show you right now. We are going to test it right now. Last criteria, no outliers. So point number 4 and point number 5, we are going to discuss right now. Okay, with the help of the data set. Now let me go with the next. Before conducting the normality test and outlier, what is my mean sample? The mean height of the prisoner is equal to 66.5. Means the sample mean of the height of the prisoners is equal to 66.5. From where I got this 66.5? This one I got it from UGC, or Bar Council of India, or particular national report, particular population census, or it can be existing research, or it can be hypothetical data based on 2 years back data, 5 years back data. I'm repeating again. This is the sample mean height that is from Gujarat that I have collected data from 50 people. I'm going to collect the data from the, as already collected data from the population mean. I'm going to compare population mean with the sample mean. Okay. So my hypothesis is that the sample mean height of the prisoner is equal to 66.5. As a part of my null hypothesis, I'm saying that there is no difference between the sample mean and the population mean. That is my null hypothesis. Whereas when it comes to my alternative hypothesis, the mean height of the prisoner is not equal to 66.5. So let me conduct the test and let's see what kind of data we are going to get it, what kind of results that we are going to get it. Before going to conduct the test, I believe you already had a session on hypothesis. I don't take much time, but I want to discuss one of the important slide with reference to the testing of hypothesis. We have 5 important stages or 5 important steps if you want to conduct any statistical test. First and foremost thing is we should be able to frame our null hypothesis, our hypothesis. That is the most important step as a part of testing of your hypothesis. Once you frame your hypothesis, you'll design the tool, you'll go for a data collection, right? So that is second stage. You're going to perform certain statistical test by choosing t-test, ANOVA, regression, whatever it is. And you're going to determine whether the data that you collected, the data that you observed, is it how if you are going to compare with your hypothesis, null hypothesis, and you'll come up with the results. If the data provides sufficient evidence against the null hypothesis, support that alternative hypothesis. If the data does not provide sufficient evidence, you cannot support alternative hypothesis, but you don't provide null hypothesis true, you merely fail to find the evidence. You always say that you fail to reject the hypothesis. You always report as a part of your research, you fail to reject your null hypothesis as a part in case if you're not able to prove your hypothesis. Now, we are going to conduct the one sample t-test. We are able to fulfill that we have one data that is height and we have independence observation. We have collected data by using random sampling. But there are 2 things we have left it. One is normality distribution. Second one is outlier. So please open the data that I have given to all. Let me open myself. I am opening the SPSS software. For the question answers, you don't need to wait till the last. At any step, you feel free to stop it. If it is theoretical part, you can have question and answer last minute. But when it comes to the SPSS steps, I'll go slowly. But still, if you feel I'm going fast, please stop me at any time. Okay. This is the SPSS format. I'm sure many of you might be using it. Many of you are experts here. Right now, I'm using version number 27, 29. Currently, if you install SPSS software, you are going to install version 31. Current version is available for version number 31. Is one of the most advanced statistical software from last 50 years, at least 40 to 50 years. This particular software is ruling the entire research industry. And it is a little bit expensive, not a little bit, it is expensive only. And we also have a few more softwares like Jamovi. It is a free and open source software. We also have R software. We also have JASP software. So these are some of the quantitative softwares that are available in alternative to SPSS. Okay. Now, if you look at this particular interface, just like any other application that we use in our day-to-day life, like MS Word, MS Office, PowerPoint, we have a ribbon bar like file. I can able to open the file. I can save the files. I can export the file. Like for example, I can export my SPSS data in the form of Excel file, CSV file. There are few more softwares like SAS, Stata, other softwares. I'm not aware of it. So we have certain multiple options. Let's say, for example, you are working on SPSS, but your supervisor is not having SPSS software. Or maybe you are consulting some expert, that particular expert is not having SPSS. So you can export this particular data in the form of Excel sheet, and you can share it to your expert or whomever you want to consult it. That is possible. You can also convert in CSV format. You also convert into other formats like SAS and SATA formats. Okay. Next one, we have edit. Right now, many of the menus are not activated because we didn't enter the data. There is a reason. Many of the buttons are not activated. Ribbon bars are not activated. View data. One can split the data. One can edit the data. One can compute the data. There are certain data transformation techniques are also available. And when it comes to the option analyze, starting from basic level to advanced level statistics are listed here. Even if you want to do it descriptive statistics, frequencies, correlation test, regression test, name it any statistical test except structural equation modeling. Most of the statistical tests are available here. If you want to conduct advanced level statistics like structural equation modeling, one has to go for SPSS Amos. SPSS Amos is another software that you have to purchase in addition to SPSS. There is another software. The name of the software is SmartPLS, partial least square structural equation modeling. If you are going to buy SmartPLS software, you don't need to buy SPSS Amos, right? So it depends on the type of statistic that you want to conduct it. One can go for SPSS, one can go for Amos, one can go for SmartPLS. In addition to statistics, one can also prepare various graphs, charts by using the SPSS format. Different kind of options are available. But when it comes to preparing charts, bars, my personal choice is always Excel sheet. When it comes to preparing the diagrams, figures, charts, I always prefer the Excel sheet because that is going to give you more options in terms of decoration, beautification, name it anything, right? So these are some of the ribbon bars. One should have some understanding about it. Now, as you all know that many of us these days collecting data by using Google Forms. So what I will do for the next 10 to 15 minutes, I'm going to explain how to enter the data manually, how to import the data if you are using Google Form. Okay. So if you want to enter the data manually, just look at my cursor. Just look at the cursor. I'm typing, my first question is questionnaire ID. What I will do, questionnaire, comma, ID. Please look at my screen. Have given the space, Q space ID. I just want to go to the next column or next tab. It is saying that variable name contains an illegal character. Means it is not accepting. There is some problem with that label name. Now let me show you right now. Q hyphen ID. Now click on tab. Means the name of the variable, this particular first column is not going to accept.
Hello, sir. Excuse me, sir.
Yes, please.
Sir, are you showing some Excel sheet or because I can see only the presentation? Are you talking about presentation only na, at this moment?
I'm showing my SPSS sheet. What about others? Are you able to see my SPSS?
Yes, sir.
Yes, sir. It is
Yes,
visible.
I can able to see your
It's visible.
SPSS sheet.
Okay, please. Thank you. Other members, please, you can check it out your maybe net connection sometime. It may happen sometimes. Okay. Yeah. Now, the first point is that it is not accepting space. Okay. Second one, I just want to start with the serial number 1, gender. So it's not accepting again, starting with the serial numbers. Okay. So what I will do is gender. Now, some people will ask, sir, how to, if it is not accepting more than one word, how to do it? For example, it is here. Let me scroll it down. Yeah. Name of the variable is questionnaire ID. Type of the variable. If I click on this particular button, there are 3 dots are available. If you click on this particular button, it is asking what type of variable it is. Is it numeric? Is it date? Is it currency? So there are different options out there. This is a numeric value. This is a numeric value. If you want to give the decimals, you can give it. If you don't want to have any decimals, you can keep 0. Just click on OK. Decimals can be, by default, width is always 8. So you don't need to make any changes. Decimals, you can decide whether you want to keep decimals or not. Okay. Now, here label, I'm going to type it here. Questionnaire ID. I can type questionnaire ID. I can give the space, I can give the full label. Whatever the label that I'm going to give, that is going to be reflecting, is going to reflect whenever I'm going to prepare any kind of table, any kind of chart, any kind of output as a part of my result. Instead of reworking, instead of making changes as a part of my output, what are the label that I want to present in my report, in my paper, I can give clear label here itself. So you don't need to do double work. Okay. For example, here I can type gender of the respondents or distribution, gender distribution, whatever the title that you would like to give it. Gender of the respondents, gender and age distribution of respondents. It depends on the context wise. You can give the specific label that you want to give it. When it comes to the values, here we are going to get values like 1 to 100, 1 to 500, whatever the sample is all about it. Whereas when it comes to the gender, as a part of my research tool, I'm going to give the code like 1 for male, 2 for female, 3 for transgender, or 4 for not prefer to share, whatever may be that. Okay. Here, I'm repeating again. As a part of the values, you can see that there are 3 dots. Just click on this particular 3 dots. The moment I click on the 3 dots, I got a new window, pop-up new window. It is asking what are the values that you're going to have. Here I'm going to give one value, label as male. Click on add. Value 2, click on, I'm going to give the name as female. Okay. So it depends on the number of groups that you have it. I can give transgender, GN. Please don't mind with the spelling mistakes. Transgender. Okay. After giving the click, just click on OK. But imagine that I have done some mistake. I want to correct it. Or I want to delete it. I don't want, let's say, for example, I don't want to have transgender. I want to make changes. What I will do, I'll go to values, click on it. I'll select this particular value and label. Just click on remove. But in case we want to make changes, I can also make changes. For example, here I will say any other, or prefer not to say share any other. Okay. Just one point I want to ask. I believe I'm not. This is fine with you, right? If I'm going to talk about how to enter the data, basics of SPSS for the next 15 minutes, or you want to go with statistical test? Is there anyone new to these SPSS? Shall I go with the statistics? Are you fine with it?
Sir, I am new with the SPSS, sir.
Please go. Go ahead.
Okay, yeah, please. Now, so this is how I'm going to enter the data with reference to the nominal variable. Similarly, I'm going to follow the same with the ordinal data. I'll show you one data like a scale. I'm talking about satisfaction of my respondents. I'm not typing the label. Here, I'm have some inventory. I'm using some construct like I just want to measure the satisfaction of employees. In order to measure the satisfaction of employees, I have, based on the existing theory or based on the existing literature, I got around 5 items, 5 statements I got it. So what I will do for the first time, I will enter the data. What is value number 1? Strongly disagree. It can be 5-point Likert scale. It can be 7-point Likert scale. Of course, it can be odd or even Likert scale as well. Even it can be 11-point Likert scale as well. Strongly disagree. Third, neutral or undecided. What is the spelling of neutral? neutral. Fourth, agree. Fifth, strongly agree. Strongly agree. Now, if it is one item, two items, I'm going to enter the data. Okay. But as a part of my theory that I have selected to test my theory, like Karl Marx theory, Abraham Maslow, whichever theory I have it, I have around 10 to 15 items, 10 to 15 statements. And all the items have same kind of anchors, like strongly disagree to agree. So what I will do, I select this particular cell. If I highlighted means I have selected this particular cell. Control C. If I'm going to have subsequent questions also same kind of anchors, Control V. Control C. Control V. What? 1 minute. Control C, Control V. Why is not happening? Copy, paste. My shortcuts are not working. So I hope you understood what I'm trying to say here. Here I can paste it. If you have around 10 items, 5 items, I don't need to type every time, each and every label. This is one shortcut we had. Now let me show you one more variable. We discussed about nominal data, ordinal data. Let's take, for
And
example,
so what about QID in fourth and fifth and sixth? It is showing VAR 00001. What about this then?
see,
Yeah.
here I'm showing this. Here I'm going to make changes, madam, because this is the item I'm going to type. For example, here I
Okay.
type item satisfaction. I'm
Okay.
talking about particular item here. So here
All
will be
right.
item, third item, fourth item.
And it is by default, is it taking in the type numeric or we have?
It will come by default, but you can make changes. If I click on this particular three dots, this particular window will come, madam.
All right. All right. Thank you
For
so
example, yeah. For example, I am talking about as a part of HR, as a part of management studies, date of employee joining, or with reference to salaries, or with reference to some currency. So it depends on the your data context wise, you can make changes. But by default, as a part of quantitative research, mostly will go for numeric. Okay. And width will be 8 and decimals, your choice. Okay. If I want to delete any of the variables, I can select on serial number 4, right click, clear. Again, clear. Again, clear. If you want to insert any variable in between, I can select the particular row, insert variable. In between or above or below that, whichever choice that you have it, we can able to do that. Next one, let me go with continuous data. Like for example, I'm talking about height. Height of the respondents. Now, when it comes to height of the respondent, we are not going to give any values labels because we are collecting data. We are asking what is your height. They're going to give their answers. But imagine that you are asking, you are giving some class intervals. Like for example, 3 to 4 inches, 3 to 4 feet, 5 to 6 feet. If you are giving that one, then again, you are going to give some labels. Like for example, here, when it comes to height, weight, age, annual income, if you want to put in the form of levels, class intervals, then again, you're going to enter value 1. Let's take, for example, 5 to 4 to 5 feet. 2. So based on that level that you required, accordingly, you can give values as a part of it. Once we give enter the data, once we enter the data, it's always better to save data time to time instead of waiting, completing the entire data. It's always better to data save the time to time. Save as.
Sir, am I audible?
If you click on the save as, it's going to come like where you want to save this particular file. Where you want to save this particular file, you can select a particular destination. If I want to save it in Indian Sociological Society, demo file. And if you look at the file extension, .sav, Like, for example, when it comes to the Word document, we will see doc, doc, like dot ppt, pptx, like that. SPSS file extension is .sav. It means this is a SPSS file. Just click on save. I got one more output window. It is showing that I have saved the file. I have saved the file. This is all about how to enter the data manually. Let me show you how we can import the data. If I'm collecting data by using Google Form or online survey, how one can import the data. So you go to File. On the left, top left side, we have the ribbon button, File. If you click on this particular file, you can open this option called Open. If you're going to open the same SPSS file, you're going to click on Open. But if I'm going to open Excel file, CSV file, in that case, I'll go for import data. I'm trying to import data from different other formats. Like I can export Excel, I can import Excel format, CSV format. Let me go with the Excel sheet. So this is as a part of bibliometric analysis, I think maybe systematic literature review. We got the data from this. It's showing this. You can able to see that I got the data, Excel data, I got the data. I am able to import it as a part of my SPSS. Only thing is, once we import the data, we have to go for cleaning. We have to go for cleaning. We have to code the data. That is the most important aspect. Okay. Now, we can save this particular data in the form of SPSS. I can save this particular data in the, I have this particular data in the form of Excel, but now I'm going to save this particular data as a SPSS format. That also is possible. Okay. You can also save it SPSS format. You can also save it as a CSV format as well. Okay. There are some options. Now just close it. I'm closing this particular sheet. Even I'm closing this particular sheet. Now, as a part of the one sample data test, we are talking about height. I already given you sample data sets. I've shared with Professor Binit sir, and he might be sharing with you all. Those are interested, maybe you can practice sometime. Let me open this particular data. Title of the file is ISS sample dataset. The name of the file is Indian Sociological Society sample dataset. That is the name of the file. Those who are not having SPSS software on your laptop or on your PC, you may not be able to open it directly, this particular software, this particular application. If you install SPSS on your laptop, you can able to open it. Okay. Now, before conducting one sample t-test, try to understand the data that you have it. As a part of my social legal research, I collected data from some prisoners in Gujarat. Like I have some data about gender, number of days they got the trial length, sentence, number of years of sentence they got it, and what kind of representation they have it, and trial outcome. Are they feeling guilty, not guilty, and what kind of crimes they have record, what kind of satisfied, how much satisfied they are, how much happiness they have, what is their height. And as a counselor, as a jailer, I have given some counseling as a part of criminal sociological research or criminology research. I have given some counseling for some of the prisoners. After giving the counseling, how many crimes they have committed, before counseling, how many crimes they have committed, So this is the general data set I have as a part of my research work.
Good.
Now, the one sample t-test that we are conducting it, the name of the variable is height. Name of the variable is height. Before conducting the one sample t-test, we have to ensure that our data are distributed normally. So in order to check whether my data are distributed normally or not, right now we are seeing the variables. Right now we are seeing all the list of the variables. At the bottom of the window, you can see there is one more view, data view. Data view. Like the data, actual data that I collected by using online form, Google Forms, okay? So variable view, data view, we have it. Now, in order to conduct the one sample t-test, go to analyze. Before conducting one sample t-test, we have to check whether my data are distributed normally or not. So I'm going to get analyze, descriptive statistics, go to analyze, descriptive statistics. If you look at the right side of this particular window, there is option called explore. As a part of descriptive statistics, there is one ribbon that is explore. Just click on it. Just click on it. We are going to conduct normality test only for continuous data. We are not going to conduct normality test for nominal data, ordinal data. It's not required, right? We are going to conduct normality test only for continuous data or interval or ratio data only. Now, as a part of my hypothesis, I just want to test my sample mean with the population mean. So I'm going to choose height of the prisoners. Height of the prisoners. I've selected height and I kept it under dependent list. Go to statistics. So 95% confidence interval. I also wanted to see outliers. Are there any outliers as a part of my research work? So I want to see, are there any outliers? Are there any responses which are deviant from the mean value? Okay, so continues. In addition to statistics, I also wanted to have histogram. I also wanted to have normality test, that Sperry-Wilkie test. I want to see normality plot, histogram, to understand whether my data are distributed normally or not. After selecting the required measures, just click on continue. Go to the options. Here, nothing to do. So in statistics, we are selecting descriptives and outliers. Continue. Plots, we are selecting histogram, normality plots with the test. Continue. Display, I want to display both statistics as well as plot. Click on OK. Click on OK. Look at the output. We got so many outputs. Let's see one by one. First one is providing the case processing summary. It is giving what is the actual data. We have collected data from 50 people and we don't have any kind of missing values. We don't have any kind of missing values. Now, next one is descriptive statistics. It is providing out of 50 people, mean height, average height of 50 people is 67.33. Average height of 50 people, mean is 67.33. Okay. Next one, test of normality. If you remember around 20 minutes back, we are talking about Sperry-Wilkie test value. If your p-value is going to be greater than 0.05, it means our data are distributed normally. In case, if the p-value is going to be less than 0.05, it means our data is not distributed normally. When it comes to conducting normality test, our p-value should be greater than 0.05 to tell that our data, whatever the data that I collected, it is distributed normally. So as per the test result, please somebody can tell me whether my data are distributed normally or not. P-value I got 0.143. Any
Yes.
volunteers? Anyone would like to?
Yes. Yes, the
It's
data is
normally distributed.
Data is distributed normally because this particular value is greater than 0.05. Okay. Now, when it comes to the PhD thesis, when it comes to the research paper, imagine that you have so much of data. You cannot prepare all the tables, charts for every single variable. You cannot prepare all the histogram, normal QQ plot, box plot, right? For talk about one variable, whether data distributed normally or not. What you can do, you can create the table, serial number 1, second table, second column, height, third column, p-value. You can give all the 20 variables, whether all the 20 variables distributed normally or not. With single page, you can able to complete it. But if you want to fill the number of pages, in addition to this particular statistical test, you can also take the help of histogram. It is nothing but it is showing whether are you able to get the bell-shaped curve or not as a part of your data. Let's take, for example, if I double click on it, I got this particular window. I can able to see that this is the mid value. I click on this particular interpolation line. This is this particular line. Interpolation line. This is one. This is the mid value. 50% of the data is falling this side. 50% of the data is falling this side. However, there are certain problems within the data. There are certain fluctuations. Overall, I can able to see some kind of bell-shaped curve. I'm not saying that exactly perfect bell shape. Anyway, this has some kind of bell-shaped curve. We have it, right? And this is perfect. This mid value is perfect. Next one, we have normal QQ plots. These are all talking about whether your data distributed normally or not. So you simply can take the values of test of normality, Spergo-Wilkie test. But somebody can ask me, sir, there is one more test, Kolmogorov value test, what it is. As a resource person, I'll present two sources here. People generally says that if your scholars generally says that your sample size is less than 2000 or up to 2000, you can rely on the values of Spergo-Wilkie test. I'm repeating again. If your sample size is less than 2000, you can take the values of Spergo-Wilkie test. If your sample size is greater than 2000, you are going to take the values of Kolmogorov test. Similarly, there is one more scholar, maybe it is a controversial part. If your sample size is small, what is the small? Generally, people say that your sample size is 50. You'll go for Spergo-Wilkie test. If the sample size is greater, larger one, we'll go for Kolmogorov test. However, you can go with Spergo-Wilkie test. 99% of the statistical test with my limited exposure, or maybe from last 10 years, wherever I have conducted training programs, whichever reports I've gone through that, Spergo-Wilkie test is the only test that we use it as a part of test of normality, as a part of your sample, irrespective of your sample size that you have it. Okay. Now coming to the normal QQ plots, as you can see this particular diagonal line, our data is supposed to be clustered or surrounded by this particular diagonal line. Almost data is there here and there except few places. There are some deviants, but however, is not affecting the normality distribution of the data. Same thing presented in the form of determinate normal QQ plots. You don't find any report talking about normal QQ plots, determinate QQ plots. Mostly you will see normality test or you will see histogram. Very rarely you will see box plot, right? So most important part is that Spergo-Wilkie test to talk about whether your data distributed normally or not. If you're not able to test your normality test, you cannot go for further statistics. If a sample size is big, very huge, in that case, even if your data is not distributed normally, one can go for parametric statistical test. Just to show you, are there any outliers here? No, we don't have any outliers. How to understand, are there any outliers or not? Let me show you my data. I'm going to manipulate my data. Let's take, for example, I'm talking about height of the respondents. If you look at serial number 1, that is respondent number 1, height is 66 inches. Please look at my cursor. I'm manipulating the data. I'm making it as 99 inches. 99 inches. I'm going to conduct again. What test? Normality test. I'm going to conduct again. Now look at the result. Look at the result here. Normality test. My data is not distributed normally just because of one respondent. Earlier I got greater than 0.05. Now it is less than 0.05. Secondly, if you look at this particular data, it is not having bell-shaped curve. It's not having bell-shaped curve. There is a lot of data disturbance. You can see that there is one data set. It is close to 100, close to 99. This is deviant from the mean value. How much distance we have? So you can see that. You can see this one. This is the deviant here. This is outlier. Look at this particular data with the help of the box plot. This is the lower level. We don't have any outliers. Upper level, there is one respondent. Respondent number 1. His height is 99. If I'm going to delete this particular outlier, my data is going to be this. It shows my data is distributed normally. Right? Now go back. Let me make it 66. Click on save. Go to analyze. Descriptive statistics. Explore. Has already given commands earlier. Just click on OK. Now look at here. It is greater than 0.05. It is 0.143. It means more than 0.05. I got the bell-shaped curve and I don't have any outliers. It means my data distributed normally and there are no outliers. After fulfilling all the data requirements, all the assumptions, we are going to conduct now one sample t-test. As we are conducting for the first time normality test, I took more time looking at PhD scholars' point of view. But in coming test, I'll go a little bit fast. Okay. If any of you are having any problem, please let me know. Okay. Now, in order to conduct the one sample t-test, go to analyze, compare means. On the right side of this particular compare means, we have one sample t-test. On the right side of compare means, we have one sample t-test. Just click on it. Now here, my variable is height. Name of the variable that I'm going to test is, my test variable is height. Select it. Either you can drag and drop it here, or you can select it and you click on this arrow. Now my test value is nothing but population mean. Somebody help me out. What is my population mean? I'm going to compare my sample mean with the population mean. Anybody can remember? Can tell me what was my population mean? As a part of hypothesis, 66.5 was my population mean. What was it? 66.5 was my population mean as a part of my hypothesis. Look at this. The sample mean and height of the prisoner is equal to 66.5. I got this particular 66.5 from census or national report or secondary data or hypothetical data. So I'm going to test my values, test value 66.5. Go to options, 95% confidence interval, continue. Click on OK. Click on OK. Now looking at this particular data, I got 3 important outputs. First one is one sample statistics. Like I collected data from 50 people and an average height of 50 people is at 67.33. That is very clear. Second one, I have conducted one sample t-test. I just want to compare. I just want to see the difference between sample mean and population mean. 66.5 minus 67.33. I'm repeating again. 66.5 minus 67.33. How much it is going to come? 0.83. Now, the difference that I'm seeing it, is it occurred by chance or is statistically significant? So whatever the difference, I'm seeing it, whether it's having any statistical significant. So in order to understand that, I started conducting one sample t-test. So if you look at the one sample t-test, my p-value is greater than 0.05. My p-value is greater than 0.05. It means there is no significant difference between population mean and sample mean. There is no significant difference between population mean and sample mean. If I get this significant difference, I'm going to talk about how much effect it is having it. I'll talk about this particular table in coming slides. Right now, let me explain how to report, how to analyze, and how to interpret the findings of one sample t-test. I know that your writing skills are better than mine. Okay, as many of your professors. But looking at some of the early research candidates, I just try to present it. Our hypothesis population value was 66.5 inches. Our hypothesis population value was 66.5 inches. The average height of the overall prisoners in Gujarat is less than 0.05. The overall height prisoners in Gujarat, if it is going to be less than 0.05, we reject the null hypothesis. If it is going to be less than 0.05, we are going to reject the null hypothesis. In our case, what happens is our result was greater than 0.05. We got result greater than 0.05. It means we are going to reject the null hypothesis. We are going to reject the null hypothesis, mean that height of the prisoners at college is equal to hypothesis mean. Means there is no much difference between 66 and 67. Hardly we got 0.85%. Based on the result, we can state that there is no significant difference. There is no, there is no significant difference in mean height of the prisoners, Gujarat prisoners, PRISON. Prisoners, Gujarat prisoners, and the overall prisoners in India are in overall prisoners, PRISO, prisoners in India. The average height of the prisoners is about, let's take for example, why I'm showing here is that I've given the value 66.5. If I'm going to reduce this particular value like 65, I'm going to get 1.5 value. But in our case, we got only 0.83. 0.83 is very minimal, very marginal. 0.83. 0.8 is not even 1 inch difference. The average height of prisoner is about 0.8 inches taller than the population mean. Population mean. So overall, the single point that I want to highlight is that if your p-value is less than 0.05, we are going to say that there is a significant difference between population mean and sample mean. But as per our result, our p-value is greater than 0.05. It means there is no significant difference between population mean and sample mean. So what we are going to do is that we fail to reject the null hypothesis. We are going to say that as it is greater than 0.05, we fail to reject the null hypothesis. Now, some of you have some doubt about what is this particular confidence interval, how to read it, how to interpret it. Let's take, for example, as a part of my test result, if I got lower bound 5.8, upper bound 5.10, it means I can say that 95% confident that true average height of all the people in the city falls between 5.8 and 5.10. This does not guarantee that true mean is in the same range, but based on the sample data, it is highly likely. Let's take, for example, simple example. I'm sure all of you might be liking Virat Kohli. Virat Kohli. we have Virat Kohli here. And the next batsman we have Virendra Sehwag. Virendra Kohli and Virendra Sehwag. My favorite batsman is Virendra Sehwag. Of course, he got retired. And when it comes to the consistency, Virat Kohli, on average, roughly on average, he may score from 50 to 75 or 100. On average, he may score between 50 to 100. 50 to 100. Whereas when it comes to Virendra Sehwag, though he's my favorite batsman, there is a possibility that he may score 0 or he may score 10 or double century, single century or triple century also he can make it. It's completely unpredictable. There's no, I mean, I can't say exactly he may get at least 50. That is there, right? Now, as a part of my test result, here we're getting the mean difference. Mean difference is 0.83. Mean difference is 0.83. Now, just imagine that as a part of our test result, we got 75 as a part of the mean score. On average score is doing 75 runs is scoring. Mean score 50, 75, 100. How much difference we have? Lower bound is 50, upper bound is 100. Upper bound is 100. Mean score is 75. Means he may score 50 at lowest minimum level. Highest level he may score 100. Highest score he may score 100. The difference between 50 to 100 is the 52 to 75 is 25. The standard of error is less. This particular value is close to the true mean. It is very close to the true mean. Here, when it comes to the 10 minus 300, how much difference we have? 290. Let's say, for example, if I'm getting a mean value like 150, 155 or 150. Distance from 10 to 150, how much? 150 to 300, how much? Based on this particular findings, I'm saying that I collected data from 50 people. I collected data from the 50 people. On average height of 50 people, height is 67. Mean height, average height is 67. But there are people who are less than 67. There are people who are greater than 67. There are people less than 67. There are people who are greater than 67 as well. Lower bound, upper bound. Less than 64, higher than 64. We call it as a lower bound, upper bound, but overall true value is this much. Now here, 0.83 is the difference, mean difference. Lower bound, it will go minus 0.49. And there is also that plus 2. There are people who are 2 inches higher. There are people minus 0.49 inches lower than 0.83. I hope you understood what I mean, what I'm trying to say. What is confidence interval as a part of your research. Only one point is that it all depends on whether you take it 90% confidence interval, 95% confidence interval, 99% confidence interval. When it comes to pharmaceutical industry, healthcare research, we'll go with the 99% confidence interval because we can't take the risk. 0.1 is the risk we can able to accept it. For example, when it comes to Covishield, Covaxin, even it is 0.1% risk, how we can take it? We can't take knowingly, right? So we'll go with 0.001 error. Whereas when it comes to social science, management, 95% confidence interval. Whereas when it comes to very rarely people go with the 90% confidence interval, means 10% margin of error. We'll have it. Okay. So this is the first test to understand how to conduct the one sample t test. So we have around 25 minutes time. Let me go with one sample, independent sample test, then we'll go for question answers. Are there any questions so far? Is it clear so far what you're going?
Yeah, sir.
Yes, sir.
Yes, sir.
Okay. Let me conduct independent sample test, then we'll go for question answers. Okay. Yeah. Now, when it comes to the independent sample test, it is also a part of parametric statistical test. The main objective of independent sample test to compare means of two independent groups in order to determine whether there is a statistical evidence that the associated population means are significant. Let's take, for example, as a part of my hypothesis, I have two variables. One is happiness. Second one, I have gender. I just want to see whether compare with the males, or I just want to compare happiness or satisfaction level of the male and female. Who is more happy? Who is more satisfied? If I want to compare the academic performance of assistant professor with the professor, if I want to compare the performance of public institutions, private institutions, central universities, state universities, CBSE syllabus, state syllabus, if I have only two groups like male, female, rural area, urban area, in that case, I'll go for independent sample test. But imagine that I have male, female, transgender, means I have more than two groups. In that case, I'll go for ANOVA test, which I'm going to discuss in tomorrow's session. If I have only two groups like male, female, urban area, rural area, public school, private school, state university, central university, name it anything, name it any context. If I have only two groups, I'll go for independent sample test. In order to conduct the independent sample test, I required two variables.
देख लिया क्या?
First variable is independent variable that must be continuous. I request the participants, please take your
प्रूफ
mic.
रीड करके देगा ना तू कैसे तो जप्सा वाले को दे
I request participants, please check your mic.
जप्सा तो बोले पप्पू दे देगा वाला कितना देगा करो ना एक बार आप उसको ही तो दिया इनको नहीं दिया चिंटू पिंटू को नहीं दिया चाची को
Udit,
पिंटू को नहीं
Professor Udit,
इसको दे दो
Professor Udit. Okay. As a part of independent sample test, I require two variables. One is dependent variable. That variable must be continuous data. It can be interval ratio. Second variable must be categorical. It can be nominal data. It can be ordinal data. Only thing is, I should have only two categories like male, female. If I, for example, as a part of ordinal data, if I'm having a Likert scale like strongly disagree to strongly agree, I can't go ahead with that. But if I have low income, high income, low height, middle height, low satisfied, high satisfied, then I can go with this is called categorical data. We should have only two categories. Independence of observation we discussed, right? Random sampling we have discussed. Normality distribution we have discussed. Only one point that I want to tell you that we conduct normality test only for continuous data, not for categorical data. Name it any test. It is a common. We are not going to conduct normality test for nominal or ordinal data. It is only required for interval and ratio data only. In addition to one sample test, we have one more additional point is that homogeneity of the variance. I have two groups like male, female. I'm assuming that there is equal variance among the groups. There is equal variance among the groups means, let's take for example, all students in this group score 90 and 95. That is my null hypothesis. And I'm going to test it whether, as per this particular test, there is equal variance among the groups or not. If there is going to be equal variance among the groups, I'll take the test of student t-test. In case, if I'm not able to fulfill the assumption of homogeneity of the variance, I'll take the values of Welch test. How I will decide whether I have to go for student test or Welch test? As a part of homogeneity of the variance test, we are going to conduct Levion's test. If the p-value is going to be greater than 0.05, it means you are able to fulfill the assumption of homogeneity. Means there is no much difference between male and female responses. There is the equal assumption, equal variance among the groups. In case this particular p-value is going to be less than 0.05, in that case, we will take the values of Welch test. Let's see how to conduct it. In order to conduct the independent sample t-test, go to Analyze. Go to Analyze. Compare means I'm not conducting normality test. We have spent more than 30 minutes as the first time we are conducting normality test. I hope it is clear how to conduct normality test. I'm directly going to show you how to conduct independent sample t-test. So as a part of compare means, we have independent sample t-test. So our data requirement is that I need two variables. One is gender. I'm taking the gender as a categorical data. It comes under grouping variable. Here I need to define the groups. Here defining the groups is nothing but how I have given the code. Some scholars, they used to give 0 for male, 1 for female. There is nothing like there is wrong and right. It's all about 1 to how we are giving coding. Only thing is you should know, you should remember how we have given coding. Like for example, male for 1, 2 for female. Continue. My test variable is happiness. My test variable is, as per my hypothesis, happiness. Just take it. Happiness score. I have selected happiness score. Options. Continue. Nothing is to do. Just give the variables. Click on OK. Just give the variable. Click on OK. Now, if you look at the happiness score between male and female, who is more happy? As compared to the female counterpart, female respondents are more satisfied. When it comes to the male, mean score is 4. When it comes to the female, it is 4.7. But the difference that I'm seeing it, whether it is having any statistically significant difference. So in order to see whether there is any statistically significant difference, I'm conducting independent sample t-test. I mentioned that there is a concept called homogeneity of the variance. If I'm able to fulfill the assumption of homogeneity of the variance, I'm going to choose first row. How I'll come to know whether I'm able to fulfill the homogeneity of the variance? If the p-value is greater than 0.05, it means there is no much difference between gender happiness score and female happiness score in terms of variance, in terms of the responses. If you look at the p-value, it is greater than 0.05. It means equal variance assumed. As equal variance assumed, I'm going to take the first row of the table. First row of the table. If this particular equal variance is not assumed, in that case, I'll go to the second row of the table. Second row of the table. Now here, as it is fulfilled, now looking at the p-value of the independent sample t-test, it is greater than 0.05. It means there is no significant difference between males and females because there is hardly how much difference? 0.73 difference, 0.7 difference, not even 1 point difference. So what are the difference that we are seeing? There is no statistically significant difference. Most of the time we'll see there is one option called effect size. What exactly it is? In order to understand the effect size, let me show you a small table. Instead of simply saying that there is a statistically significant difference, I just want to tell how much effect it is. For example, if my test value, how much I got the value here? 0.39, 0.39. I got the Cohen D value, 0.39. Okay. If it is statistically significant, I need to refer effect size only when I get the significant results. In our current case, there is no statistically significant difference. Imagine that we got significant results. Instead of simply saying there is a significant difference between male and female, I also wanted to add one more line. There is a significant difference between male and female, and it has this much percentage effect size. Like, for example, if my value is less than 0.2, small effect. If I want to convert into percentages, 58% effect. If this particular value is between 0.2 and 0.5, it is a medium effect. That is nearly 69-70% effect. If it is 0.8, near 0.8, it is called large effect. If it is above 1.4, 1.59, then huge extensive large effect. You can give different names as a part of your data analysis and data interpretation. So this is what for today, and I will be session open for question answers. Any question? I'll try my best to answer your questions. Otherwise, I'll get back to you tomorrow. Please feel free to let me know if there are any questions.
Thank you, sir. Dear participants, those who want to clarify your doubt, please, you can ask any
Uh,
query.
Yeah, there are a couple of people raised their hand. Dr. Anu.
Good evening, sir.
Good evening, madam, please.
Very good session, and I got a lot of insights actually.
Thank you, madam.
Actually, I was doing this work quite a few years, since quite a few years. But now I heard that thing while doing the Shapravic test for normality, you suggested that thing more than 2000, we
If
should
it is
go
less than 2000, you can go for Speriovic.
Shapravic. More than 2000 means we have to go with the Kolmogorov, right?
Yes, madam.
And if one more statement you have given that I'm confused, if the Shapravic test is significant, but sample size is more than 200, still we can go with the parametric test, right, sir?
If your samples is more, means minimum it should be 380, 400.
380 or 400?
Above 400.
Above 380, and still the test is
And
significant.
one more point.
Okay.
It also depends on your total population size, but in general, above
In
380
general,
considered as a good sample.
good sample. Then even if it is a test is significant, we can go with the parametric test, right, sir?
Yes, madam.
Okay,
Yes.
thank you, sir.
Please welcome. Thanks a lot. Thank you. Next, Dr. Professor Samir.
Sir, in the
Good evening, sir.
SPSS data which you had entered,
Sir, if you don't mind, can you a bit loud?
you had used the Likert scale and used the measure as nominal instead of ordinal.
Somebody can help me out what he's asking, Professor Samir. Can you type your question, sir? Please, don't mind. In the meanwhile, Bhagyavati.
Good evening, sir. Thank you for the session, first of all.
Thank you, ma'am. Thank you.
So you're telling whenever there is deviation, like if at all, say for example, I want to check the performance of my students. Say for example, 10 students. Out of that, 9 students have scored the marks within 5, and 1 student has scored 95.
Okay.
So you told that we have to remove that outliner.
If it is because of that particular outlier, if it is
but
normality data. That is one option. Second option is that you can increase your sample size. Okay.
And if at all, I have only 10 students in my class, say. So I should not take the mean at all?
No, ma'am, because that is affecting the overall. One person is having what are the other people? One person is 10.
And the other are within 5. Within 10. That means there is marginal difference between this one person who has scored 95 and other people have scored less than 10, other 9. So that time we are not supposed to take the mean at all, or you take the mean but remove that outliner. What do you say? Like how
For
the
example,
thing?
you have 10, you are saying that you have 10 students, right?
Yes.
And what are the values? Starts like roughly?
Okay. 10.
Okay.
8,
Okay.
11,
Okay.
some 13, whatever, within 15 I can say, and one out of that, one student has scored 90 plus or something.
No, madam, you cannot take that figure, that particular outlier, because that is going to affect the entire. You're going to tell all the members that mean score marks are very high, right? That is not correct, right? That is not the true value. So either you can delete that particular outlier,
Okay.
or you can increase your sample size.
That's the only
That is
thing.
all.
Like as I told, I have the limitation of my sample size I have to take. So what is the other alternative I can go?
You can delete that outlier.
That's the only method.
That is the only option that you have. Yes.
Okay. Then it is going to affect my result, right? Like I can say that, see, one of my students has scored 95. If at all I take average only for that 9 students who have scored less marks, then
In that case, see, for example, your sample size is 10. You cannot go with any statistical test also. You can simply go with single frequency cross tabulation, that part. You don't need to test. How you're going to test your hypothesis with the 10?
Okay. So there are two options. One, increase your sample size, or I'll
Yes.
remove that outliner.
Yes.
Thank you.
Before going to a few more questions, I've shared one Google YouTube link here. This is my YouTube channel. If somebody interested, if you are interested, go for 10 hours SPSS or Jamovi, qualitative data analysis like Atlas TI, NVI, Vivo, or any kind of writing research paper. Please subscribe to this particular channel if you are interested or if you like the content. Yes, please. Next.
Sir, am I audible now?
Yes, sir. Please, sir.
Yeah, the data which you had entered in SPSS, I could see that there you used the Likert scale, and
Yes.
the measure selected was nominal instead of ordinal.
Nominal instead of ordinal. I didn't make any changes. I just showing you how to enter the data.
So shouldn't we be selecting the measure as ordinal for Likert?
I already told you that ordinal Likert scale is ordinal data only, right? As a part of theory, I have mentioned that.
Okay. Thank you so much.
Because, yes, please. Please, any more questions further, please? Thank you for all your feedback.
Sir,
Thank you.
can we do jet test with the help of SPSS?
Can we?
Can we do jet test?
Jet test. Yes, madam. I haven't done it, but yes, you can do that test. Mostly people use Excel sheet for conducting the jet test. Maybe tomorrow I'll check it and get back to you. Definitely, I can try. Okay.
Okay, sir.
Please. What is your good name? So that tomorrow I'll get back to you.
Apesha.
Alpesha.
Apesha. Yes, sir.
Apeksha.
Yes,
Okay,
sir.
madam. I'll get back to you tomorrow, please.
Okay, sir.
Any questions? Any one of you?
Sir,
Yes, madam, please.
Sir?
Sir,
Sir,
is it mandatory to do normality test? Every statistical
If you are going for parametric statistical test, it is mandatory. If you are going for non-parametric statistical test, it is not required. And if you are going for descriptive statistics, it's not required. If you are going for only inferential statistics, the two only parametric, then you have to go for it. Second, as I already mentioned, if you have only quantitative data, like interval ratio data.
Okay.
Thank you so much. Thank you, everyone. Thank you for your feedback. Was the session is going slowly, or is it sufficient, or going fast?
No, sir, it was perfect.
Sir,
Yes.
I have a question.
Please, madam.
Sir, normality test is for the taking decisions regarding the selection of either use the probability or non-probability techniques. Am I right or not, sir?
Probability, non-probability, not madam. For every statistical test, every inferential statistics test, if you want to go for parametric, we have to test whether your data distributed normally or not. And as you are talking about probability, non-probability, even your data must have collected by using random sampling. There is also another important assumption to go for parametric statistical test.
Okay, sir. Yeah. Thank you, sir.
Please. Manisha Singh, please. You can unmute yourself. I've shared one ebook with the
Oh, good
organization.
evening, sir.
Yeah, please.
Sir, in independent sample test, can you explain homogeneity test again?
Yes. As a part of independent sample test, we are having two variables. One is independent variable, like categorical data, where we have opted for gender, male and female, right? Second variable is dependent variable. Now, as a part of this particular categorical data, as a researcher, I'm assuming that I collected data from my students about marks. There should not be much variance between male students and female students in terms of their variance. Let me show you that particular slide if I have that slide. Let me share my screen once again. Hmm. Just 1 minute, please. See, I'm just collecting the data from my students, and I collected data from 1, 2, 3, 4, 5, 6 students as a part of the example, just example. And these are the scores of the students, and these are the scores of the females. These are the scores of male students, these are the scores of the female students. Now, we are going to get the total. That total will be difference. The sequence, the number, the difference that we have it, are there drastic differences between the male students and female students in terms of number of marks we got it from each? I'm saying that there is no much difference between male and female students in terms of their marks. So for that, I'm going to conduct Levian's test. The Levian's test is going to help me to understand if I'm able to fulfill the assumption. If my p-value is going to be greater than 0.05, I'll say that I'm able to fulfill the assumption. There's no much difference between male students and female students in terms of their marks. If my p-value is going to be less than 0.05, I'm not able to fulfill the assumption of homogeneity, right? So based on this test, Levian's test, I'll decide whether I have to go for first row, second row of the independent sample test. Second row or of the independent sample test. I'm able to make it the difference, madam? Is it clear?
Yes, sir. Thank you so much, sir. Thank you.
Yes. Please, any questions further, please?
Okay, thank you, sir. Now we come to the end of today's enlightening session. Thank you, sir, once again
Thank you,
for
ma'am.
your wonderful and enlightening session about how to analyze the qualitative data by using with different beautiful examples. Tomorrow, their participants tomorrow will have the continuation of today's session. So their participants, please join on time. Thank you very much, sir.
Only one request is, if it's possible, you can join with a laptop or PC if you want to practice it. Okay, that is one request.
Yes.
Thank you so much. Thank you, everyone. Thank you, ma'am.
Thank you, sir. Good night, everyone.